Hello everybody, welcome back to our video series on Surds. As you can see by the title, today we will be looking at the rules of Surds. What can we do with them? Well, broadly speaking, for two Surds, A and B, there are two things that we can do with them. Broadly speaking, we can multiply them or we can divide them. We can't add and subtract them because they don't have any intuitive meaning. Unless you approximate the surds, which, as I said in the last video, you shouldn't do. You should just leave them as they are. You can't factorize them out or do anything with them. You have to leave them in the form square root of a plus or minus square root of b. What we don't end up with is the square root of a plus or minus b. These are different. Unless a and b are 0. That is the only instance in which this holds. This whole equality holds. So we can multiply and divide them. Well, that's okay. So what do we have when we do this? Well, if we have the square root of a times the square root of b, we have the square root of a times b, which is equal to the square root of ab. Now, why is this? Well, it's because if you cast your mind back to your powers rules, if we have a to the power of b times a to the power of c, we have a to the power of b plus c. But we also have something very similar to this. If we have a to the power of c times b to the power of c, then what we have is a times b all to the power of c. These are kind of equivalent, but ultimately they sort of exist on their own. So as you can see, in this case, in the case of a square root, we have that c is equal to 1/2, but ultimately c could be 1/3, c could be 1/4, c could be anything. But this is the case in our case, in our case, where c is equal to 1/2. What else can we do? Well, by the same principle as this, it shouldn't take too much of a stretch to work out that if we divide them, we have the square root of a divided by b. So that covers the basics, but what else can we do? Well, suppose we take a number, n, and times it by a surd. We can go this way, which is to write everything in terms of a square. So we could take the square root of n squared, this will give us n, and times it by the square root of a, and this will give us the square root of n squared times a. But more often than not, you will actually be going back the other way. So what do I mean by this? Well, if you have the square root of n squared times a, this will equal the square root of n squared times the square root of a. And this will equal to n times the square root of a. This is how we usually leave surds. Just a note here, n does not have to be a whole number. You could have n squared equal to maybe 1/9, or 4 over 25. Or you could just have 16 or 25 or 81. The list is quite literally endless. But in essence, these are the most important rules you need to learn. There is one more thing. It's called rationalizing the denominator. Remember in the last video we spoke about rational and irrational numbers. If we have some number of the form a divided by the square root of b, nature does not like that surd being in the denominator. Nature doesn't like that, so we need to correct it. So how do we correct this? Well, we multiply by the square root of b divided by the square root of b. And why? Because this is equal to 1. And this will give us a root b divided by root b squared, which will give us a root b divided by b. And then we have something of this form. This is a over b root b. So this process of getting rid of this irrational number in the denominator, this is called rationalizing the denominator. This is also a completely equivalent way of writing it. You could have a root b over b. These are totally equivalent. You could write either of these in the exam, you'll be just fine. So that just about covers all of the rules. Naturally, the rules of fractions still apply. If you have the square root of, for example, I'll switch back to black for the time being. If you had the 1 over the square root of a plus 1 over the square root of b, the question could be, for example, write this in the form a root, c root d, where c is some rational number and d is an integer. You would do as we just said. You would times by a over a, because this is just equal to 1. You don't have to worry about doing this to the other side. And this would give you root a over a. And then again, you would have plus root b over b. And then you just have basically a fraction. You could multiply both sides by b over b. So you could have root a over a times b over b plus root b over b times a over a, just like you would do in any adding fractions question. And then you would have b root a plus a root b over ab. Obviously in this case you wouldn't be able to write it in this form, but if you worked through your steps and left it just like this, that won't be a problem. If this is a bit confusing, just go through and see all the steps I've taken and make sure that you're familiar with this concept. All this is just adding fractions by the rules of adding fractions. So, thank you very much for watching. I hope you found this helpful, and in the next video we will look at some examples. Thank you very much.